This is a very interesting question. A block of ice starts sliding down from the top of the inclined roof of a house. Angle of inclination of the roof is 30 degree to the horizontal along the line of maximum slope. The highest and the lowest parts of the roof are at the height of 8.1 meter and 5.6 meter respectively from the ground. At what horizontal distance from the surface point will the block hit the ground, neglecting the friction? So first we are going to draw the basic projectile figure. So this is the horizontal plane and this is the vertical height of the maximum point of the roof, and this is the slope. At this point, after this point rather, it starts to move in this direction as a projectile. So let us call this as point A, this point B, this C, this D, and let us call this E, and this point as F. So the ice is at point A and it starts to slides across this slope AB, and ultimately after point B it projects itself with the velocity V, and its angle is given as 30 degree. AD at the topmost point is given as 8.1 meter and the lowest point is given as 5.6 meter. So this distance AC, if we substitute AD and DC, this will be coming as 2.5 meter. So we already know that the vertical distance traveled by the block before the point B, we can write here the vertical distance traveled by the ice is equal to AC, which we already found is coming as 2.5 meter. Now let us suppose that the V is the velocity at point B. Let V is the velocity of the block at point B. So initially the block was at rest, so we can say that initial velocity will be equal to 0. We already said that velocity at point B is V, so we can say the final velocity is equal to V, and acceleration will be equal to g sine of theta, where theta is 30 degree, and the distance S will be equal to AB, that is traveling in this direction, so that will be our S, and we can say that sine of 30 will be equal to AC by AB, that is in triangle ABC. So we are going to use the formula V square minus U square is equal to 2AS. So V square is 0, so this cancels out, so we get V square is equal to 2as. So v square is equal to 2. Acceleration is g sine 30 and s is given as ab. Sine 30 is ac by ab, so we can write 2 into g ac by ab into ab cancels out, so we get v square is equal to 2a multiplied by ac, and ac is 2.5. This will be 2 into 9.8 into 2.5. This will be coming as 49. So v will be coming as 7 meter per second. Per second. Now we can divide this velocity v into two components, horizontal as well as vertical. So this will be the horizontal component, this angle is theta, so this will be v cos of 30, and this will be a vertical component, that is v sine of 30. So the horizontal component of velocity, horizontal component of velocity, which is given as ux, will be equal to v cos of 30, or ux will be equal to 7 into square root of 3 divided by 2, giving us ux is equal to 3.5 square root 3. Similarly, we can find out vertical component of the velocity. Vertical component of velocity is equal to uy v sine of 30. So uy is equal to 7 multiplied by 1 by 2. This gives us uy is equal to 3.5. This will be meter per second, and this will be also meter per second. Now let us suppose that after point B, the time of flight of the ice is given as small t. Time of flight after point B is t. Then considering the vertical motion, we get sy is equal to u by t plus half a by t square, where sy is distance in y direction, that is 5.6. uy we already calculated is 3.5, and acceleration in y is g, that is 9.8. So substituting these values, we get this as 5.6 is equal to 3.5 t plus half 9.8 t square. Now this is quadratic in t. So we can write this equation as 7t square plus 5t minus 8 is equal to 0. So we can find out value of t as minus b plus minus square root of b square 4ac divided by 2a. this will be coming as -5 plus minus 15.78 divided by 14. So ignoring negative value of t, ignoring negative value of t, we get t is equal to -5 plus 15.78 divided by 14. This will be coming as 0.77 seconds. Now considering the horizontal motion, considering horizontal motion, the horizontal distance covered by the projectile, which is equal to EF. So horizontal distance is EF, which is equal to horizontal velocity, that is ux, multiplied by time of flight. Ux we already know is 3.5. So u of x is 3.5 square root of 3 is time, which was 0.77. So we get EF is equal to 4.688 meters. Then the total distance was df, which is equal to dE plus EF, and dE we can find out as dE is nothing but equal to BC, which is equal to AC cot of 30. AC is 2.5, cot of 30 is square root 3. This is 4.33 meters. So we can say that DF is equal to 4.33 plus 4.688, and the total distance is coming as 8.988 meters. Thank you.